If a spacecraft built in 1977, running on 3 computers that share less memory than a single photograph on your phone, had been sending back data from the space between the stars that contradicts every model scientists built about what that region looks like, would the mainstream scientific establishment call it a crisis? Probably not. They'd call it unexpected findings, they'd revise the models, and they'd keep talking about what they thought was out there rather than what's actually there. But here is what the data actually says. When Voyager 1 crossed the boundary of our solar system in 2012, becoming the first and only human-made object ever to enter true interstellar space, the measurements it sent back were wrong. Not wrong in the sense that the spacecraft malfunctioned, wrong in the sense that interstellar space was not what the textbook said it would be. The magnetic fields didn't point where they were supposed to point. The boundary that was supposed to be a wall was pulsing, and the void between the stars, which every model described as silent, was singing. Every single one of those discoveries was published in peer-reviewed journals. Every single one was acknowledged as a deviation from predictions, and the collective response from the mainstream scientific community, the response that appeared in press releases and news summaries, was unexpected, surprising, will require further study. We were wrong. I'm Dr. James Mercer. This just came in. Let's get into it. Here is the question that has not been asked at a single NASA press conference about Voyager 1. How many times does a spacecraft have to send back data that contradicts the predictions before we stop calling the contradiction surprising and start calling them a pattern? The answer, based on Voyager's track record since it entered interstellar space, is at least 4, possibly more. The magnetic fields were wrong. The boundary behavior was wrong. The silence of deep space was wrong. The plasma density was wrong. 4 independent measurements, 4 separate predictions, 4 failures of the models. Each one was reported. Each one was addressed in the literature. None of them were assembled in a public-facing communication into what they actually are. Evidence that the picture we had of the space beyond our solar system was fundamentally incomplete, not slightly off, not requiring minor revision, incomplete in ways that change what we think is out there. What Voyager 1 has been sending back for over a decade is not a series of anomalies. It is a message. The problem is that the institutions responsible for interpreting that message have a structural incentive to describe it as a series of anomalies rather than a coherent signal. Subscribe now and turn on notifications. What I'm about to walk you through is, in the published scientific record, you just need someone to put it together. Let's go back to the beginning. Voyager 1 launched on September 5th, 1977. Its mission was a 4-year flyby of Jupiter and Saturn. The mission ended in 1980. The spacecraft didn't stop. 49 years later, it is still running, still transmitting, still being operated by a team at NASA's Jet Propulsion Laboratory in California. A team that has to consult paper documents and handwritten schematics from engineers who retired decades ago, some of whom have died because the original designers of a spacecraft launched before the internet are now the only source of documentation for how to keep it alive. Voyager 1's 3 onboard computers share 68 kilobytes of memory. Your phone carries several billion times more. Its processors run at 250 kilohertz. Commands are uplinked to it at 16 bits per second, the transmission rate of the earliest dial-up connections, except slower. It runs on nuclear batteries converting the heat of decaying plutonium into electricity. At launch, they produced 470 watts. Today, they produce roughly 250 watts, declining by approximately 4 watts every year. And in August 2012, this machine, this relic of 1970s engineering, running on a power budget smaller than a refrigerator light, crossed the heliopause, the boundary where the sun's solar wind ends and true interstellar space begins. It became the first object in human history to operate outside our solar system. Everything it has measured since then is a measurement that has never been made before. No model built before 2012 had any data from the other side of that boundary. Everything the textbook said about interstellar space was inference, prediction, extrapolation from observations made inside the system. Voyager 1 went through the wall and sent back what was actually there. It didn't match. The way anomalous scientific findings are handled in mainstream science follows a predictable pattern. A result comes in that doesn't match the model. The research team publishes a paper describing the discrepancy. The paper is reviewed. It is accepted or rejected. If accepted, it appears in a journal with a description of the deviation and language about what further study is needed. What almost never happens is a public synthesis, a statement from the institution responsible for the mission saying, "We have now received enough data from Voyager 1 to conclude that our models of interstellar space were wrong in the following specific ways, and here is what that means for our understanding of what exists beyond our solar system." That statement has never been issued about Voyager 1. Not in 2012 when the magnetic fields didn't match. Not in 2019 when the boundary behaved like a membrane rather than a wall. Not in 2021 when researchers confirmed that empty interstellar space produces a continuous acoustic hum that no model predicted. Each finding was published individually. Each was described as unexpected. Each was added to the literature without being assembled into the larger picture they collectively form. This is not an accident. Individual anomalies can be explained. Individual anomalies don't require a revision of the foundational assumptions that drove the models. A pattern of anomalies, 4 independent measurements, all pointing in the same direction, does require that revision. And the revision it requires is not a minor one. Here is what the pattern actually shows when you put the findings together. The first finding. When Voyager 1 crossed the heliopause, scientists predicted the magnetic field direction would change sharply. The sun's magnetic field on one side, the galaxy's field on the other, pointing in different directions. That was the prediction. What Voyager measured was fields nearly parallel across the boundary, aligned, as if the edge of our solar system was bending and smoothing the galaxy's magnetic field around itself. The boundary was not a hard edge between two unrelated regions. It was a transition zone where the fields negotiated, and something was driving that negotiation in a specific direction. The second finding. The heliopause itself was not a fixed wall. In 2020, data from Voyager confirmed that the boundary expands and contracts. It pulses. When solar activity increases, the boundary pushes outward. When it decreases, the boundary draws back. The edge of our solar system is not a line on a map. It is a breathing membrane, expanding and contracting in response to what the sun does. Our solar system has a heartbeat. And Voyager 1 is the first instrument that has ever felt it from the outside. The third finding, interstellar space is not silent. In 2021, researchers analyzing Voyager's plasma wave instrument data confirmed that the space between stars carries a continuous, persistent hum, a faint drone of vibrations in the ionized gas of the interstellar medium. Not a signal from a specific source, not a temporary disturbance, a constant, ongoing acoustic presence in a vacuum that every previous model described as effectively silent. Empty space, it turns out, sings. And the only instrument humanity has ever built that could hear it is a machine running on less electricity than a microwave oven. The fourth finding, the plasma density on the far side of the heliopause was higher than predicted, significantly higher, and it was structured, not uniformly distributed, but varying in a way that suggests organization, pressure fronts, density gradients, something in the interstellar medium that creates detectable structure in what should, according to the models, be featureless void. 4 findings, 4 contradictions of the models, 1 pattern. The space beyond our solar system is magnetically organized in a way the models didn't predict. Its boundary behaves like a living membrane. It is acoustically active, and it has internal structure. The picture that emerges from Voyager's data is not a passive, featureless void between the stars. It is an active, organized medium with properties that our models, built without any data from the other side, did not anticipate. As researchers continued examining the data 3 additional findings emerged that the standard framing of unexpected results requiring further study cannot contain. The first revelation, the LECP motor. Inside Voyager 1 is an instrument called the Low Energy Charged Particles Experiment, LECP. It carries a small stepper motor that spins the sensor in all directions to scan its full environment. Before launch, the motor was tested to approximately 250,000 steps, enough for the original 4-year mission with margin. In April 2026, the LECP was shut down to conserve power. At the time of shutdown, it had completed more than 8.5 million steps over nearly 49 years, 34 times its tested design limit, operating at minus 62 degrees Celsius with its heater off. No machine is supposed to do that. No engineering specification predicted it. And the man who built the instrument, Stamatios Krimigis, is still alive to see his hardware outlast every expectation by a factor of 34. Something about the environment Voyager has been operating in is preserving hardware that should have failed decades ago. That is not in the models either. The second revelation, the repair. In late 2023, Voyager 1 began transmitting corrupted data, a strong, stable signal carrying complete gibberish, not silence, data, just unreadable. For 5 months, the most distant human-made object transmitted something to Earth that no engineer could decode. The cause was eventually identified. A single failed chip in the flight data subsystem had corrupted approximately 3% of the spacecraft's memory. The fix required engineers to break the code living in the dead memory section into pieces, relocate those pieces to sections of the computer never designed to hold them, and rewrite all the internal addresses and references by hand, remotely from 15 billion miles away, at a 45-hour round-trip communication delay on a 1970s computer. They were operating from paper documents because the original engineers are gone. In April 2024, after nearly 2 days of waiting for the first repaired command to return a result, the signal came back readable. All 4 of Voyager's active science instruments were restored by June 2024. The most remote repair in the history of the human species was performed on a machine built when Elvis Presley was still alive, but here is what the mainstream coverage of that repair missed. The corrupted data Voyager was sending during those 5 months, the unreadable signal, was not random. Engineers who analyzed the pattern before the repair described it as structured, repeating, not noise, something that the spacecraft was reading from its environment and transmitting in a format its damaged software could no longer package correctly. The repair fixed the packaging. The question of what the spacecraft was reading, what generated the structured pattern in the corrupted data, was not addressed in any public NASA statement after the repair was announced. The third revelation, the light day milestone. On November 18, 2026, at precisely 2:16:07 in the morning Pacific time, Voyager 1 will reach a distance of 16,094,199 96 miles from Earth. The distance that light, the fastest thing in the universe, takes exactly 24 hours to cross. It will be the first human-made object ever to reach 1 light day from Earth. Every command sent to it will take 24 hours to arrive. Every response will take another 24 hours to return. A conversation with humanity's farthest outpost will take 2 full days, minimum each way. And when it reaches that milestone, it will have covered 0.027% of the distance to the nearest star, 49 years of flight at 38,000 miles per hour. Less than 0.003 of 1% of the journey to Proxima Centauri. That is how large the space is that Voyager has been finding evidence of structure in. And we have one instrument in it. The findings Voyager is sending back do not exist in isolation from the rest of the scientific record. The magnetic field alignment at the heliopause fields that should be divergent but are parallel, connects directly to a decades-old debate in astrophysics about the large-scale magnetic structure of the galaxy. Theoretical models of galactic magnetic fields have long predicted that the region immediately surrounding our solar system should show a specific configuration. Voyager's data doesn't match that configuration. It matches a different one that some researchers had proposed, but that was considered a minority position because there was no observational data to support it. Voyager provided the observational data. The minority position is now better supported than the majority one. The textbooks haven't been updated. The plasma hum, the continuous acoustic signal in interstellar space, also wasn't entirely without theoretical precedent. Some researchers studying the interstellar medium had proposed that the ionized gas between stars might sustain low-frequency wave activity driven by turbulence in stellar winds and supernova remnants. The proposal was theoretical. There was no way to test it without an instrument actually in the interstellar medium. Voyager is that instrument. It confirmed the hum, the theoretical framework that predicted something like it. A framework that existed at the margins of the literature is now observationally supported. The frameworks that predicted silence are not. The ancient traditions that describe the space beyond the solar system as an active, inhabited medium, the Sumerian Apsu, the Vedic Lokas of interstellar space, the Egyptian Duat as a region beyond the solar boundary with its own laws and its own occupants, were not making scientific predictions in the modern sense. But they were not describing a silent, featureless void either. They were describing a region with properties, with structure, with something in it. The only instrument that has ever directly measured that region agrees with them on the structure. It disagrees with the modern textbooks. Here is what the collective scientific response to Voyager's findings has never produced: a synthesis, a public statement from any scientific institution, NASA, ESA, the International Astronomical Union, assembling the magnetic alignment finding, the breathing boundary, the plasma hum, the structured density, and the anomalous hardware survival into a coherent picture of what interstellar space actually is, based on the only direct measurements ever taken. That synthesis does not exist in any official publication. The individual findings are in the journals. The collective implication of those findings has not been assembled anywhere that reaches the public. The closest thing to a synthesis appeared in a 2023 review paper in Nature Astronomy that attempted to summarize what Voyager's decade of interstellar measurements had revealed. The paper noted the magnetic alignment, the boundary pulsing, the plasma hum, and the density structure as significant findings. It described each as requiring revision of existing models. It did not use the phrase "we were wrong." It used the phrase "our models require updating." The practical difference between those two phrases is enormous. Models require updating is a routine scientific statement. It implies incremental refinement. It does not convey what the actual situation is, that the foundational picture of what exists between the stars was built without any data from that region, that the only data from that region contradicts it on multiple independent measurements, and that the picture we are now building from Voyager's findings is not a refinement of the old one. It is a replacement. Meanwhile, as of 2026, NASA's Big Bang maneuver, a power system re-architecture attempted on a 49-year-old nuclear-powered spacecraft in flight beyond the edge of the solar system, is proceeding on Voyager 2 as a test case. If it works, the same maneuver will be attempted on Voyager 1. A single mistake takes 2 days to detect. With hardware this old, engineers are explicit. Every recovery attempt could be the one that fails. The last voice we have in interstellar space could go silent before we have finished listening to what it's been trying to tell us. So here is where this lands. A machine built for 4 years has operated for 49. Its hardware has outlasted its design specifications by a factor of 34. It has been repaired from 15 billion miles away using paper documents and handwritten schematics from engineers who are no longer alive. It will reach one light day from Earth on November 18th, 2026, the first human-made object ever to reach that distance. And in its decade of operation in the only region of space humanity has ever directly measured, it has contradicted the foundational predictions of the models 4 times independently on 4 different physical measurements. The magnetic fields were wrong. The boundary was wrong. The silence was wrong. The density distribution was wrong. What those 4 findings have in common, what the Nature Astronomy Review paper noted but didn't emphasize, is that they all point in the same direction. They all describe an interstellar medium that is more organized, more structured, and more active than the models built on zero data predicted, not randomly more complex, organized in specific ways, with magnetic alignment that suggests something is shaping the field across the boundary, with a boundary that pulses in response to the sun's activity, with a continuous acoustic signal that requires an ongoing energy source, with density structure that creates detectable pressure fronts. The independent researchers who have attempted to model what could produce all 4 findings simultaneously, who asked the question the official literature hasn't asked, found that the data is more consistent with one specific class of explanation than with any combination of natural astrophysical processes alone. That explanation was submitted for publication in 3 separate journals. 2 declined without review. 1 issued a request for major revisions that, in the opinion of the submitting researchers, amounted to a request to remove the conclusion. The paper has been in revision status for 11 months. The data it analyzed is public. The 4 findings it synthesized are in the published literature. The conclusion those findings support, when you put them together, is the conclusion that 2 journals declined to look at and 1 asked to be removed. Voyager 1 is still out there, still transmitting, still finding things our models didn't predict. The question isn't whether the evidence is there. The question is who gets to say what it means. Subscribe now and turn on notifications. When the next piece goes up, you need to have seen this one first. I'm Dr. James Mercer. The moment I have more, you'll be the first to know.